Welcome to Study Loop.
Okay, so we know the mass flow rate can be equal to A1 V1 over specific volume of V1 here. So A1, which is the inlet area, is given as 50 centimeters squared. If we convert it to meter squared, it's about 5 times 10 to the power negative 3 meters squared. And we know the inlet velocity, which is V1 here, is equal to 60 meters per second. And at 4 megapascal, 40 degrees Celsius, the specific volume for the superheated steam is about 0.07343 meter cube per kilogram. Okay, you can check the table A6 at the book. I'm sorry, at the back of the book. Okay, and if we plug in back to the equation, we'll have the mass flow rates is equal to A1, which is 5 times 10 to the power of negative 3 meters squared, and then times 60 meters per second over 0.07343 meter cube per kilogram. And this will give us the mass flow rate is about 4.09 kilogram per second. For the next question, while we know the rate of energy that was transferred in minus the energy that was transferred out should be equal to the d system over dt, which is the rate of change of energy in the system. And in this case, should be equal to 0 because it enters in steadily. So therefore, we have the rate of change. The rate of energy that was transferred in is equal to the rate of energy that was transferred out, which is E in dot equal to E out dot. If we expand it, we have m dot times h in plus 1/2 v1 squared is equal to m dot times h out plus 1/2 v2 squared plus q loss dot. M dot is the mass flow rates, h in is the enthalpy at the inlets, v1 is the inlet velocity, and h out is the enthalpy at the axis, v2 is the exit velocity we're looking for to determine this question. And Q loss dot here is the rate of the heat loss. So if we do some arrangement here, eventually we'll have V2 is equal to square root 2 times H in minus H out plus V1 squared minus 2 Q loss dot over M dot. So we know at 4 megapascal, 40 degrees Celsius, the enthalpy is equal to 3,214.5 kilojoule per kilogram. If we convert it to meter squared per second squared, it's about 3,214.5 times 10 to the power 3 meters squared per second squared. And at 2 megapascal, 300 degrees Celsius, the enthalpy of the steam, the superheated steam, is about 3,024.2 kilojoule per kilogram. If we convert it to meter squared per second squared, it's about 3,024.2 times 10 to the power 3 meter squared per second squared. And we know inlet velocity is given as 60 meter per second. We know the mass flow rate is 4.09 kilogram per second. And we know the heat loss rate is 75 kilojoule per second. So therefore, if we plug in back to the equation, we'll have the exit velocity, which is V2 here, is equal to square root 2 times H in minus H out, which is 3214.5 times 10 to the power of 3 meter square per second square minus 3024.2 times 10 to the power 3 meter square per second square, and then plus V1 square, which is 60 meter per second square, and then over and then minus 2 times 75 kilojoule per second over 4.09 kilogram per second. And remember, we need to convert it, the kilojoule per kilogram here into a meter square per second square. So therefore, we need to multiply by 1,000 here. Let me see. Okay, and the unit is meter square per second square. So this will give us the exit velocity is about 589.5 meter per second. And for the next question, while we know the mass flow rate can equals A2V2 over specific volume 2. So therefore, I have the exit area is equal to m dot times specific volume 2 over V2. So we know the mass flow rate is given as 4.09 kilogram per second, and we know the exit velocity, which is calculated, which is 589.5 meter per second. And at 2 megapascal, 300 degrees Celsius, the specific volume for the superheated steam is equal to 0.12551 meter cube per kilogram. If we plug in back to the equation, we'll have this exit area is equal to 4.09 kilogram per second times 0.12551 meter cube per kilogram over 589.5 meter per second. And this will give us the, you know what, let me go to the next slide. Okay. So this will give us the exit area is about 8.71 times 10 to the power of -4 meter square. If we convert to centimeter square, it's just simply 8.71 centimeter square. And these are the answers for this question.